Hello everyone, welcome to Chandra Awesome. In this today's video, we're going to learn about how to design this radial engine. So, as we already, you have me, sorry, you have already watched the video of this animation where shorts. Let's today start designing with this, how to design and how to approach this animation within Onshape CAD software. Okay, so let's begin the tutorial where I already have the parts. So let me explain you how to design the parts individually. So let's create a new part studio. Okay, here we are. Okay, switch to select front plane, and actually we need uh the actual positions. So I'm going to use inscribed polygon or scribe in which one you want. Okay, and select it, draw it, expand it, and give it to 5 sides because I choosing the 5 sides. If you want more, you can increase the size as you want. Okay, so currently I'm focusing on only 5 sides. I'm choosing this. It just aligned perpendicular to it. Okay, I think it's done. Okay, it's aligned. Now let me give the dimension. Let's give 3 inches. So these are the actual positions of pistons should be aligned here. Okay, so now we need to draw the pistons and the body. So here the actual one. So this is the actual figure. This is one we have to draw first. This is the plate. So where this plate should be connected to the pistons. Okay. So let's switch to the Part Studio 2. And now we already give the dimensions. Let's select the circle and add some holes here. Let's give the dimension to 0.5. That's fine. I'm going to choose pattern, circle pattern, select the circle and give the value to 5. Press enter and select with the mouse key so they should be aligned automatically. Okay. Now we need to do one more thing. Just select the offset tool, select the lines, and make sure it should be outside of it because these are the actual holes. Okay, that's why. Currently it should be 0.31. Let's give to 0.32. Okay, that distance is enough for us. Now let me add asset to hole as well corresponding to the shaft dia. So let's give it q2.1. Sorry, typo 1. I think it's too big, right? Let's give it a point 0.8. Okay, now save the sketch. Now select the sketch regions and leave these holes as it is and click on extrude. Give the thickness to 0.1 or zero point 0.2 as you want. I'm choosing 0.2 and selecting the offset because we need to draw the center part, which is I think what a crankshaft. So that's why I just moved it. And also we need to make sure it fit between these plates. Okay. So let's give the offset distance to 0.2. I think that's fine, or let's give to 0.25. That's fine. Okay, let's give 0.2 and save it. Now select the fillet tool, select the edge, right click, select, okay, and equal length to the already suggests. So all will be selected automatically. And let's give the value to 0.2 or 0.3. Okay, now they are aligned. Now save it. Now select the mirror tool. There is a mirror. Okay, select the part, select mirror plane, select the plane, reference plane, and save it. Oh, we got it. Okay, now what we need to do here now, let's draw the pistons. I'm going to select the front plane, select the sketch, and I'm going to draw the line. And let's use tool. So the line should be, the piston rod should be aligned. So I'll draw a line like this. Now give the distance. It should be 2. Okay, that's fine. Okay, let's give 1.5 and select the center point rectangle. Draw the piston head. So it should be square, right? So select two sides and select equal tool. So they get equally aligned. And now give the dimension. Do you think the pistons are small? Piston is still small. Okay, let's give the 2 and let's give the value to 1 or 0.8. Are they good now? Let's give it. Okay. Think now please the one value makes it perfect fit. Okay, that's fine. Let's leave it like this. Okay. Now draw the middle line connected to it. Now select the curve and make sure it has some, the piston head should be having some curve on the top, right? So make sure to align. Give me the random value, so it should be aligned like this. Okay, now I'm going to select the center point rectangle again and draw the fits. Okay, give the dimension to it 0.01 and the length should be 0.02. That's fine. Okay, give the distance from the bonnet 2.03. Okay, now choose the linear pattern. Now select the all lines and this direction value should be 1, and we have another direction as well, that is should be in this direction, and give the value to 3, and this should be 0.02. Okay, we should give the value to 0 point in negative value. Okay, should do for, let's give minus 0.02. Okay, now save it. Now if you want more things you can add it there. I think it's too small. Giving the value to 0.01, let's give 0.05. Okay, and the value to 0.1. Okay, let's 0.05, and the middle distance should be 0.05. Okay, and it's 0.05. And the distance should be 0.03. Okay, minus 0.08. I think that makes sense now. Am I right? Well, listen to my audio file. Okay, now that's good. And let's give this radius to, we need a some bump. That will divide to 20. Okay, that's fine. Now, save the sketch. Now let's draw the piston right now. Okay, select the revolve tool, select this face, and here choose thin tool. We don't need solid because we need a hollow region and something axis. Okay, currently thickness is not high enough. I think it is not high enough to rotate. Okay, I think because of the thickness, let me edit the sketch and give this initial value. Point one. Okay, now let's try again. Selecting, select this space, select revolve axis. The value to 0.01. Come on, it's not rotating. The 0.001. Let's try with the solid. Okay, the solid sub is working. Let's do the other board cake around. Okay, save it. What happened is we need to extra operation, that is shell. Oh, it is working maybe because of, we don't know. Let's give the thickness to, yeah, thing. Let's go to 0.03. Okay, that's fine, I think. Now save it. Okay. Show the sketch. And now let's draw the connecting rod. Select extrude and choose thin and make sure it is symmetric. And the value should be 0.2. Sorry, the depth. Should be zero point 0.4. Okay. Yeah, it is 0.4. Now do the same thing for the thickness. Let's choose midplate. Give the value to 0.4. Okay, that's good. Let's hide the piston. Okay, that's fine. Everything is fine. Okay, that much is enough. Now save the sketch. Now we're going to do is show the sketch one. Select the extrude, choose the thin, and select the edge, and choose symmetric value, and give the same yellow, that is 0.4. And right now we need to give the thickness to 0.1. Okay, that's too much. If we change the direction, it should be closer like this. So we need it to upside Okay. Okay, that's fine. Point one is fine. Let's keep it like that. And make sure it is add and that to the piston connecting rod. Now save it. Now, now select the whole sketch, choose extrude again, and it should be solid right now. Okay. Sell the sketch once again. Instead of new, select remove and make sure it should be symmetric and it should be aligned with this. And once you added the megascope part, it will remove the extra material of the reference part. Okay, now save it. Now just hide the piston head. Okay, this should be the center, so which means we need to draw an extra sketch here. Just hide the sketch too. You don't need anymore. Set one, select use tool, and select circle and align to it like this. Okay, and you need to do extrude. Let's select the offset tool and make sure it is inside of it. Minus 0.03. Just select the arrow, it will change the direction. If not, 2.0. Okay, it's changing. Double click to save. Now save the sketch. Select the regions and extrude symmetric. Give the value to 0.4 and save it. Now I just build the sketch 3 once again. I hide this for right now and make sure it is visible. Now make sure the part 3 is also visible and select extrude, select remove, select symmetric and select connecting rod as well as piston head. So we get the holes like this. Okay. Now save it. Now we can hide the sketch 3. So we got everything and can also hide sketch 1. We need the connecting pins here. Okay. So before doing that, do you think it's too much? I think the piston should be a bit bigger, right? Let's set the sketch 2. So that's fine. Okay, we got something. Shit. And just increase the depth. Okay, now we got it. It got adjusted. Make sure it's visible the sketch 1 and sketch 2. One is to draw the pins. Make sure it should be drawn separately because I will tell you why. Okay, give the direction, make it symmetric. The value is 0.4, but the thickness is 0.2. It should be 0.6. Okay, it should be a new part, not a added part. Okay, now select extrude tool again. Okay, we need this center. Make sure the symmetric. Okay, it should be symmetric. Okay, the should to face. Okay, if symmetry is don't work, use the second hand position. So you can manually adjust it. Okay, select up to face, select it, and there you go. The pins are exactly aligned to the curve face. Okay, and save it. We got everything. We just need to pattern it. Okay, just hide the sketch. Okay, we got piston head, connecting rod, pins, and center part. Now we need to draw the body and also the crankshaft. Okay, so in order to draw the crankshaft, let me show you the actual image. Okay, so let's hide the body. So if you observe clearly, the input shaft direction it is far from the output connecting one, or else the output shaft. Okay, so this is the input one, which actually the pistons rotated, and this is the output one, which actually give the output force. Okay, so if we rotate it, okay, just a second, select it. Okay, sorry, we are in the part studio. Got it. Need to draw like this, just like set. Okay, and the crankshaft should be like this, and the body should be drawn like this, and the head should be like this. Okay, so let's switch the part to. Now select the front plane, select sketch, select circle, and give the maximum value as much you can. Okay, actually it should be calculated, but I will give the actual design to you. But I'm the this video is basically for understanding how to achieve the shapes and animations within the Onshape CAD software. Okay, currently I chosen this value 6. Okay, that's fine. Or else let's increase to 6.5. Okay, that is perfect. Now I'm going to size center line and make sure it is construction. I'm going to select this center, and the head is like this. Okay, I know these values we don't need. I'm just going to trim them because we don't need those. Now select dimension, give the value to 3. Oh, I got it. Let me connect like this and make sure it is construction. Okay, I think I need to equal these two lines. Now let me give the dimension. Now it's work. Okay, but the direction is not aligned because of I deleted the value. Let me show you how to correct it. Just simply select this line. Actually, it is already horizontal to this, but make sure it is parallel to the piston connecting rod by choosing the parallel construction, so it won't bend on other direction. So I can adjust the value how much I can. Okay, it's currently 3.8, 2.8 value, and this one should be 1.2, 1.8. Okay, let it be like this, or else we can. Okay, let's keep it like this. That's fine. Okay, everything good. Let's pattern it because we need all directions, and make sure it's not now. You can unconstruction it by selecting the tool because we need to rotate here. Okay. Now save the sketch. Now select one side of the plate. Select front plane. Select sketch. We need to draw the crankshaft. Select use tool to project the inner circle, and I'm going to select some 3-point arc, not 3-point arc. I'm going to select center point arc. Now select the center. It should be inside this. Start one corner and end with another corner. That's you draw the center point arc. Now select the lines. The line and draw a bit down because these should not be aligned straightly. Now let's give the value. It should be 1.5. Okay. Now choose slot. You can find its slot here. Select it and make sure it is aligned to the actual value. Okay, point is actual value. Now select lines and make sure they align like align to these one. Now let's give the dimensions. Let's choose the angle between them. Let's give the value to 100, which means it should be 50. Okay, now they are aligned. But we actually didn't give the, let's give the radius. Let's give set it to 3. Let's give 3.1, 3.2. That's fine. And let's give the value, it should be 2, and equal these two lines using equal tool. Okay, I think that much in is enough for the crankshaft right now. If you want, you can use, okay, let's save the sketch. Just hide the sketch 4. Just select the crankshaft sketch. Select extrude. As you see, it is not currently aligning or not constrained actually, because we it got selected as add. Okay, So let's keep it as new and let's give the value to 4.2. Okay, that much is enough. Let's choose straight offset because it should be offset something enough. So the shade blindness, I'm going to give 0.3. Okay, that is fine. Okay, I'm going to select the fillet, select the edges, right click, select equal. Let's give the value to 0.1. Okay, that's fine. Okay, one more thing we have to do. Just make sure visible the sketch once again. Select this face, select sketch. We draw this self front plane, draw the circle, and make sure it is aligned to the center by pressing I and select the uh, previous edge and the circular edge and select I again to get it intersect. Okay, now save it. Now let's extrude it out. Let's give it the value as it is and do the same thing here. Select extrude and the direction should be other side and keep it as add and the sheet should be matched with this and we need to give these, let's choose symmetric, not symmetric. Okay, let's choose both directions. Oh, cool. Let's get to value 1.5. Now save it. Okay, everything is clearly done. Let's work with the body. Okay, then the circle. Make sure it extrude out. Choose symmetric. Make sure the middle part should be hidden and the piston head also should be s- space enough. Okay, let's give the thickness to 2. Okay, 2 is fine. It make sure it should be new. Select it. Now select this one. Select this region. Select revolve and now select the thickness. It definitely work right now. Choose revolve axis. I think there is something wrong. The revolve tool. Okay, I should. I need to select the edge. I'm so sorry. I'm just confused. Maybe. Keep it neat. Okay, cool. I better choose solid. I can make it slot later. Okay, it's with the wall. The edges are still not being covered. Okay, let's save it. Let me increase the thickness a bit. Let's give it a 0.1. That's fine. Okay, I'm going to slot it by choosing shell tool. The shell. Hold on a second. Let me pattern it first. It should be 5 and it should be added and it should be added to this part and save it. Now select the shell tool. Now select this one and make sure that thickness is enough, and the head and the body should not be intersected. Okay, so for in order to check that, right click on the front plane and select section view and save it for now, and you will show the parts are actually getting interacted. So see, they get intersected. So let's edit the shell and change the thickness to outside. Now it got aligned. Okay, okay, you can use your project sheet. Okay, okay, that's fine. Now everything is perfect. Now make it hello. Okay, now it is hello. Save it. What you just need to do, everything the partition is completed. Just in order to come out from the section view, select the square box on the right side and turn off section view. Okay, let me split it because I need to assemble it. Select the part entities, it is front plane, and set. And then if you hide this one, I can see the parts. Okay, every part is perfect. Now we need to do the assembly section. Okay, uh, I will show the I will show you how to assemble these parts in the next video, because the design part itself is very long. I don't want to make you bored. Okay, let's watch the assembly section in the next video. You can watch it from there and assemble it. Okay, if you really like this channel and if you want to give me any feedback, please let me know. It definitely helpful for me to improve. Okay, thank you for watching.